Yes. Hello friends, we'll see the continuation. In the last session I discussed about different desirable static characteristics of instrument. Then in this session we'll continue with the undesirable static characteristics. Then we will start with the dynamic characteristics also. Okay. The characteristics is eighth one. One of the undesirable static characteristics of instrument is hysteresis of an instrument. Yes, hysteresis of an instrument. How to define hysteresis of an instrument? For example, let us consider a 0 to 10 ampere ammeter. Okay, a 0 to 10 ampere ammeter. For a 0 to 10 ampere ammeter, for using this ammeter, we are doing one experiment in increasing order. Okay, this is input and output we are giving. For input of 0 amperes, I am getting output is also 0 ampere. For input of 2 amperes, I am getting output is 1.6 amperes. For 4 amperes in input, I am getting 3.8. For 6 amperes of input, I am getting 5.6 amperes. For 8 amperes of input, I am getting 7.4 ampere. For 10 amperes of input, I am getting 9.7 ampere. Let us assume that example I am giving. For different values of input in increasing order, I am getting the outputs like this. By using same ammeter, we are doing the experiment in decreasing order. Okay, this is input, this is output. We are doing experiment in decreasing order. Yes, for 0 amperes of input, I am not giving started at 10 amperes of input. I am getting 9.8 amperes. For 8 amperes, I am getting 7.6 amperes. For 6 ampere, 5.8 I am getting. For 4 amperes, 3.9 I am getting. For 2 amperes, 1.8 I am getting. For 0 ampere, 0.5 amperes I am getting. If any instrument gives the readings like this, different readings, for same values of input, in increasing order and decreasing. In increasing order, inputs are same. In decreasing order also, inputs are same. But outputs are different we are getting. Then we can say that that instrument is having hysteresis characteristics. If it is getting like this, then only hysteresis is having. No sir, maximum in practical I will get the same value. You getting the same value means then that instrument is not having hysteresis. That is the meaning. Mainly these hysteresis characteristics can mainly seen in the case of MI type instruments. That's why if any instrument gives different readings in increasing and decreasing order, different readings in increasing and decreasing order for same values of input, then we can say that that instrument is having hysteresis characteristics. That means if any instrument gives different outputs in increasing and decreasing order, different outputs for same values of input, in increasing and decreasing order, then it is having hysteresis characteristics. For example, if you draw the characteristics between input and output in both increasing and decreasing order, let this is output and this is input. In increasing order, I am getting the characteristics like this. In decreasing order, I am getting the characteristics like this. Then we can say that this instrument is having hysteresis characteristics. This instrument is having hysteresis characteristics. Okay. Then this is the output values in increasing order. This is the output values in decreasing order. Point to remember, due to hysteresis, the output values in descending order, this is decreasing order, is more than as compared to output values in ascending order. That means due to hysteresis, output values in descending order, is more than output values in ascending order. Next, one more point to remember. Due to hysteresis, the loading and unloading curve is not coincidence. This is loading curve and this is unloading curve. This loading means increasing. This is unloading means decreasing. If the loading and unloading characteristics are same, for example, we may get the characteristics like this also. If you draw the characteristics between output and input. In increasing order, I am getting the characteristics like this. In decreasing order also, you can get the same characteristics. Then you can say that that instrument does not have any hysteresis characteristics. In increasing order, I am getting one characteristics. In decreasing order, I am getting another characteristics. Then we can say that that instrument is having hysteresis characteristics. That's why due to hysteresis, the loading and unloading curve, okay, unloading curve is not coincidence. The loading and unloading curve is not coincidence. Okay, because of hysteresis of instrument. But what is the reason for hysteresis? The main reason for hysteresis is because of storage elements. Hysteresis is mainly due to storage element. Hysteresis mainly due to storage elements. Which are the storage elements present in the instruments? Springs, magnetic field, all these are stored. Whenever storage elements are present in increasing order, the storage will store the energy. In decreasing order, it cannot respond suddenly. Once it cannot respond suddenly, whatever the property offered in the increasing order, whatever the property offered due to storage element in the decreasing order is not same. That's the reason why we are getting different values. That means the reason for hysteresis is mainly due to storage element. Hysteresis is mainly represented as a maximum value of hysteresis, as a maximum value of full scale. Then the maximum value of hysteresis is given as H by Q maxima minus Q minima. This is Q minimum value. The change here from this it is started. This is Q minima. Then you take this is Q maxima value. This input and this you take the Q maximum value. Then this Q minimum value and this Q maximum value. Then the maximum value of hysteresis is given as H by Q maxima minus Q. Like this you can calculate. As a scale range, we can define the maximum hysteresis. Okay. This about what exactly hysteresis of a instrument. Hysteresis is one of the undesirable characteristics. Clear? Concentrate. Quick. Note down. The another undesirable characteristics of instrument is dead zone, dead time and threshold, that you will see. What is the dead zone, dead time and threshold of an instrument? This ninth one, dead zone, dead time and the threshold of an instrument. To explain this, here I am drawing output and input characteristics with respect to time. Let us consider output and input characteristics with respect to time. This output and input is taken on the same axis and this is the time. Output and input is taken on the same axis and this is the time. Now I am getting the characteristics like this. This output and input characteristics, I am getting the characteristics like this. Then this is called dead zone of an instrument. This value is called dead zone. Okay, and this is called dead time of an instrument. This value is called threshold of an instrument. Take this one. This is called measuring lag. In detail later on I will explain what is a measuring lag. This is one of the dynamic characteristics. This value is nothing but a dynamic error. But here mainly I am explaining what the dead zone, dead time and threshold. In detail about dynamic error and measuring lag later on we will see. Yeah, tell me what is the dead zone of an instrument? How to define dead zone of an instrument? Yes, this is input and this is output. Okay, let we are continuously increasing the input, but still I am not getting any output. We are continuously increasing input, but the output is not started. We are continuously increasing input, but output is not getting. Continuously increasing input, output is not started. At this value of input only output is started. This change in this input value is nothing but a dead zone. Dead zone is not a time, this is the input value. We are continuously increasing input, at a particular value of input only output is started. That is called dead zone. Then how to define dead zone of instrument? How to define dead zone of an instrument? Yes, the maximum change in input for which output is not detected is called dead zone of an instrument. That is, note down this, the maximum change in input. The maximum change in input for which output is not detected. Yes, for which output is not detected. Not detected. Yes, is called dead zone. The maximum change in input for which, this is the maximum change in input value for which output is not detected, this is called dead zone. Then what is the reason for dead zone? Dead zone is mainly due to inertia of instrument. Dead zone is mainly due to inertia of instruments. This is due to inertia of instruments. Okay, this is about what is the dead zone. Can you define what is the threshold of an instrument? How to define threshold of an instrument? Yes, we are continuously increasing the input. At this value of input only, the output is started. Yes, the minimum value of input at which output is started, that is called threshold of an instrument. Don't confuse with threshold and resolution. Resolution is change in input value for which output is detected. But threshold is the minimum value. That is not a change in value, that is the minimum value at which output is started. That is nothing but a threshold. That's why the minimum value of input, the minimum value of input, the minimum value of input at which output is started, output is started, yes, is called threshold of an instrument. Threshold of an instrument. Okay, this point you remember. Then what do you mean by dead time? What do you mean by dead time? Yes, it is the time taken by the measurement system to begin to respond for a change in measurement value, for a change in input value. That is, it is time taken by measurement system. It is time taken by measurement system, to begin to respond, for a change in input value, is nothing but a dead time. Okay, this about what exactly? Dead zone, dead time, threshold. Dead time only the time, remaining threshold and dead zone is input values. All are input values. Okay, this about one of the undesirable characteristics of an instrument. Quick note down. Okay. Now we go for another undesirable characteristics of instrument is drift of an instrument. Concentrate on drift of an instrument. Another undesirable characteristics of instrument is drift. The name itself, it indicates that drift means it's a deviated from actual value. Okay. Then mainly there exist three types of drifts. One is zero drift characteristics of an instrument. Okay. Zero drift characteristics of an instrument. How we can get zero drift characteristics means, if you draw the characteristics of instrument between input and output, you are drawing the characteristics between output and input. Okay, then drawing the characteristics between output and input. Actually, let us assume that these are the nominal characteristics of instrument, or these are the actual characteristics of instrument. But practically I am getting the characteristics like this. This is practical character. These are the nominal characteristics, actual characteristics, and these are the characteristics due to drift. Characteristics due to drift. These are true characteristics. I am getting characteristics due to drift. The drift is started from 0 itself, and throughout measurement the drift is constant. Then it is called zero drift characteristics of an instrument. This is a zero drift characteristics of an instrument. Throughout measurement the drift is constant. Clear? Yes. The reason for drift, this is mainly due to external electromagnetic fields. It may be due to external electrostatic fields, or may be due to vibration. All these are the different reasons for production of drift in an instrument. Due to some vibrations also, and due to some electromagnetic and external electrostatic fields, the drift may be present. This type of characteristics you see even in the laboratory also. In some instrument, the meter will not start at 0. It may be above 0 or below 0. Then without correcting that one, if you start the experiment, let assume that already pointer is at 1 volt. If you give the 0 volts input, then meter shows the 1 volt. If you give the 1 volt input, the meter shows the 2 volts. Like that, the drift remains constant throughout the measurement. Then in that case, what you do in the laboratory? By adjusting the screw, first we can bring the pointer to 0 position, then we can start the experiment. Understood? Sir, what is the reason for this change in that pointer above 0 or below 0? Maybe some vibration effect, or due to some external or electromagnetic or electrostatic field. That is the main reason. Okay. Next, another characteristic is span drift or sensitivity drift. Yes, span drift or sensitivity drift of instrument. Sensitivity drift. Then how we can get the span drift or sensitivity drift means, in any instrument, if you draw the characteristics between output and input, this is output and this is input. These are the nominal characteristics. These are true characteristics. Nominal characteristics. But because of drift, these are the characteristics due to drift. If any instrument is having the characteristics like this, then we can say that that instrument is having span drift or sensitivity drift characteristics. Throughout measurement, the drift is increases from nominal value. That is, this is characteristics due to drift. Characteristics due to drift. Throughout measurement, the deviation is increases. Then we can say that that is the span drift characteristics. Okay. Then one more drift characteristics, zonal drift characteristics of instrument. Yes, zonal drift characteristics of instrument. Then how to define zonal drift characteristics? The zonal drift characteristics means the name itself it indicates up to some portion only we can get drift. Remaining portion we don't have any drift. Then that is nothing but a zonal drift characteristics. These are the nominal characteristics. These are the nominal characteristics. That is the characteristics due without drift. Nominal. That is the true characteristics. But due to drift, we are getting the characteristics like this. Then it is called zonal drift characteristics. Means up to some portion only we can get. Remaining portion there is no drift. We can get the actual values. That is nothing but a zonal drift characteristics. Okay, for all these drift, only reason is external electromagnetic and electrostatic fields and vibrations. Different reasons are there. Okay. Then the point to remember, if any instrument we are getting the characteristics like this, we are drawing the characteristics between output and input. In any instrument, I am getting the characteristics like this. Then these characteristics are, there is a drift at 0, and if the range increases, drift is also increasing now. Then this is the combination of both zero drift plus span drift. Zero drift plus span drift characteristics. It is a combination of zero drift and span drift characteristics. Clear? Concentrate. This is about one of the undesirable characteristics of a instrument. Then one more undesirable static characteristics of an instrument is static error. In detail about this later on I will explain, but what the meaning of static error means? It is error under static condition. The static error is nothing but a error under static condition. In detail about later on this I will explain, but we can define static error under static condition. Then it is defined as epsilon naught, static error epsilon naught equal to measured value minus true value. But error may be plus or minus, then it is taken like this. If the fundamental formula for static error is measured minus true, it's not true minus measured, that point to remember. Measured value minus true value. Then if measured value greater than true value, then error is positive. Error is positive. Sorry, measured value, yes, error is positive. Then correction should be negative to make the error is 0. Correction should be negative. If measured value less than the true value, then error is negative. Error is negative. Then correction should be positive. Correct? Correction should be positive. For example, measured value 4 volts, true value 1 volt, or true value 3 volts I am getting. Then what is the error? 4 minus 3, that is 1 volt. This 4 minus 3, 1 volt. To make the error is 0, how much we can add? Minus 1 volt. That's why if error is positive, correction should be negative. If error is negative, correction should be positive. Okay, this error under static condition is nothing but a static error. In detail about that I will discuss in the error analysis in the next chapter. Okay, up to now you remember error under static condition. Okay, all these whatever the characteristics I explained, these are the static characteristics of an instrument. Then you go for dynamic characteristics of instrument. No need of in detail discussion of dynamic characteristics. That I want to list out the dynamic characteristics of instrument, mainly concentrate on the definition of a dynamic characteristics. Okay, listen please. The second characteristics is dynamic characteristics of an instrument. Dynamic characteristics of instrument. These are the characteristics of instrument under time variant condition. These are the characteristics of instrument under time variant condition or under dynamic condition. Now, what are the different dynamic characteristics of instrument is? One is speed of response. Speed of response. Speed of response. The another dynamic characteristics is fidelity of an instrument. Fidelity of an instrument. Fidelity of an instrument. Third one is measuring lag. Measuring lag. Measuring lag. Fourth one is then dynamic error. Dynamic error. Okay, these are the dynamic characteristics of an instrument. Okay, speed of response, fidelity, measuring lag, dynamic error. Speed of response and fidelity, these two are desirable dynamic characteristics. Desirable dynamic characteristics. Measuring lag and dynamic error, these are the undesirable dynamic characteristics. Undesirable dynamic characteristics. Tell. Question may be expected like this: which of the following is desirable dynamic characteristics? Which of the following is undesirable dynamic characteristics? To answer that, you remember this. Next, how to define speed of response? Speed of response is a desirable. Every instrument must respond at very fast. Giving input, suddenly we can get output. Like that, instruments are acceptable. Okay, that is how fast the instrument will respond. How fast the instrument will respond. The instrument will respond is called speed of response of an instrument. The name itself, it indicates how fast the instrument will respond. Fidelity, that I will explain. What is the measuring lag? Name itself, measuring lag. Delay in the response. Delay in the response. Measuring lag is nothing but a delay in the response. Is nothing but a measuring lag of an instrument. Dynamic error, the name itself, it indicates that. Error under dynamic condition. Yes, error under dynamic conditions. Error under dynamic conditions. Error under dynamic conditions is nothing but a dynamic condition or time variant condition is nothing but a dynamic error. Then speed of response, measuring lag, dynamic error, the name itself, it indicates. Then what do you mean by fidelity of an instrument? This important characteristic. What do you mean by fidelity of an instrument? This is one of the desirable dynamic characteristics of an instrument. Yes. Speed of response is acceptable. Every time the instrument must respond fast. At a very fast rate, it must respond. That is acceptable. But every time the instrument is responding at fast rate, but every time it is showing the wrong reading. We are giving input, we are getting output. Giving input, getting output. But every time the meter is showing the wrong reading. Is it acceptable? No. Then what the fidelity will say? That means it is the speed of response of an instrument with minimum dynamic error. That is acceptable. The instrument must respond at very fast, but at the same time, error should be minimum. That is the fidelity of an instrument. That is, it is the speed of response of an instrument. Yes. It is the speed of response of instrument. Response of instrument with minimum dynamic error. Okay, with minimum dynamic error. Dynamic error. Okay, this about the dynamic characteristics of an instrument. This what is static characteristics and what are the dynamic characteristics. Okay. Yeah, this about in detail about characteristics of a instrument. I discussed about static characteristics and dynamic characteristics. Maximum based on this dynamic characteristics, up to now questions are framed. That is based on these definitions only. You can expect one question is framed like this: which of the following is desirable dynamic characteristics or undesirable dynamic characteristics? Like these questions are framing. But in static and dynamic characteristics, you see the previous GATE or IES questions. Many times the questions are framed in the static characteristics only. Rarely the question, one or two questions are framed. Mainly in GATE instrumentation, the question is framed from the dynamic characteristics. Okay. With this, characteristics of instrument is completed. Okay. Thank you. In the next session, we will continue with the new concept. Okay. Clear? Thank you.